Alright, so far we've talked about the algebraic definition of division. We've talked about rates and ratios. Division kind of encompasses the whole chapter 6. Rates and ratios are kind of their own little group. 6.4 is kind of the start of another section regarding division, and this is relative frequency and probability. Hopefully this sounds familiar because the activity that you did prior is all about relative frequency and probability. So in this lesson, we're just hopefully going to solidify some of those ideas that you gathered while doing the activity. The big thing I want out of this lesson is to understand the difference between these two things. Because I see so often students just kind of meshing them into one thing, and there is a big difference. There's also similarities, but understanding that difference I think will help us keep the two things straight and understand them better. Okay, so relative frequency we can talk about in terms of the two words that make up the definition. Relative, when somebody says it's all relative, it's all in regards to that specific situation. And frequency is how often something occurs. Okay? In the book, you will see notation that looks like this. So here's where the division comes in for chapter 6. And what these two things are talking about is the frequency in which something occurred divided by the total number of opportunities. And again, hopefully with the activity that we did, this is kind of linking to that so you can see what I'm talking about with frequency and then total number of opportunities. We'll do some more examples as well. We can write relative frequency as a percent, a fraction, or a decimal because it is a ratio. Okay, so this is just a ratio, again comparing frequency of something occurred to the total number of times. So it's a ratio, so we can write it as a percent, a decimal, or a fraction. So just keep that in mind. Okay? So let's look at example 1 in your book. And this is on page 370. The Illinois Department of Public Health reported that for the years 1980 to 1990, 3,840 skunks were examined for rabies. Of that number, 1,446 actually had rabies. In that time, from 1980 to 1990, what was the relative frequency of skunks with rabies among those tested? Okay, we're asking for relative frequency because it's for this specific situation in Illinois in these years. These skunks were examined, okay? So it's relative to this situation, okay? So relative frequency of skunks with rabies, okay? So going back to our definition of relative frequency, what is the frequency that something occurred? Well, we're looking for the fact that they had rabies, okay? And 1,446 actually had rabies. And then what was the total number of opportunities? Or in other words, how many could have had rabies? Well, there was a total of 3,840 skunks actually tested. Okay, so those are the two numbers that go along with frequency that something occurred and total number of opportunities. Okay, again, this is a ratio, so we could write this as a decimal, a fraction, or a percent. So if we divide 1,446, 3,840, we end up with 0.38, which is 38%. If we want just to look at the reduced fraction, it looks like 241 over 640. I would say for this problem, the percent is probably the most helpful because it tells us 38% of the skunks that were tested had rabies. Okay, so that's relative frequency. If we look at this problem, could 0 of the skunks we had tested had rabies? Sure. Could all 3,840 of them had rabies? Sure. So we can always look at relative frequency. It's going to be between 0 and 1. 0 being, if I had 0 as my numerator here, it would be 0 divided by this number, which would give me 0, or 0% of them had rabies, versus if 3,840 of them, so all of them, this would be 100%. So this is talking about the decimal version, between 0 and 1, or 0, 100%, in terms of those two values in any relative frequency. Okay? So then let's look at probability. The big difference, like I said, we want to understand the difference. The big difference between relative frequency and probability is that probability is more general and it's based on theory. And when I say theory, I mean when we flip a coin, in theory, it's a 50-50 shot of getting a heads or a tails, okay? If I would flip a coin 10 times, am I guaranteed to get 5 heads and 5 tails? No, that would be relative frequency because it's that specific situation. But probability is the general idea, in theory, what should happen, not necessarily what is going to happen, okay? So that's kind of the big difference in understanding of those two things, okay? With probability, we have some more notation that the book uses, and our notation is going to look like this. And what this is saying is the probability of an event occurring. So the event is I'm getting heads, or I'm rolling a 6, or I'm getting the Queen of Hearts. So that's the event, is equal to the number matching the event over the number of outcomes. Okay, so if you look at these two ratios, they are very, very similar. The big idea, the big difference though, is relative frequency is an experiment, a specific situation. Probability is the general theory, what should happen. Okay, let's try example 2. Hurricanes happen often enough in some states that public officials must have evacuation plans ready. If hurricanes are equally likely to occur on any day of the week, what is the probability that one occurs on Saturday or Sunday, the number of times there are the fewest people in schools and offices? Okay, so we're looking at probability now. So I want the ratio that compares the number matching the event that I'm interested in versus the number of outcomes, okay? And this is asking, what's the probability that it's going to happen on Saturday or Sunday? Well, how many days are Saturday or Sunday? 2. So that's the number matching my event that I'm interested in. How many outcomes are there? Well, the hurricane could come on 7 possible different days, Sunday through Saturday, okay? So here's my probability that the hurricane is going to occur on Saturday or Sunday, assuming that it's equally likely that they happen any day of the week. Again, we could write this as a decimal or a percent. All right, example 3 talks about cards. So this is a fun example. A standard deck of playing cards has 52 cards. There are 4 suits: clubs, diamonds, hearts, and spades. Each suit has 13 cards, an ace all the way up through 10, jack, queen, and king. So those are the 13 cards. Suppose you shuffle the cards well and pull 1 card at random. Find the probability, that's what that P stands for, of getting the ace of hearts. Okay, so probability, our numerator, or our first part of the ratio, is always what matches the event. So ask yourself, in the deck of cards, how many are the ace of hearts? 1. There's only 1 of those. And how many cards could I have possibly drawn? 52. So that is the probability of drawing the ace of hearts. Okay, part B, what is the probability of drawing a queen? Well, there are 4 queens. Still 52 cards. I could reduce this, simplify this into 1 over 13. And that makes sense because 1 out of every 13 cards should be a queen. 1 out of every suit, which a suit is a total of 13 cards. So I think that makes sense. Okay? Also, when we talk about probability, there is something called complementary event. Okay? And complementary event is all of the other stuff. Okay? So if we go back to the hurricane problem, a complementary event would be, what's the probability that it doesn't happen on Saturday or Sunday? Okay, so that would be all of the other stuff. Okay, so complementary event is all of the other. If we think about this, a complementary event, if we have the events we're looking for, so Saturday, Sunday, and the complementary, Monday, Tuesday, Wednesday, Thursday, Friday, those should always add up to our total. So that would be our 7 days, or all 100%. Okay? So let's look at example 4 and use that idea. A weather forecaster reports that the probability of rain tomorrow is 70%. 70% chance that it is going to rain. What's the probability that it does not rain? Okay, so this is the complement. What's all of the other? Okay, we know that 100% is our total, so what's the probability that it does not rain? 30%. Okay? This table is really, really good because it talks about the differences of relative frequency and probability. Okay? Relative frequency is an experiment. Probability, it's theory. Assumptions based on theory, general idea. The other one that's really, really important, and this is the one I want you to focus on, is number 3. If I have a relative frequency of 0, that means in my experiment, the event never occurred. A 1 or 100% would mean the event occurred every possible time it could. Versus in probability, the theory, the expected, 0 means the event is impossible. A 1 would mean that the event is sure to happen. It's going to happen every single time. So that's a big one, number 3, okay? You could go on and talk about these some more. If you're interested in looking at them, I'd be happy to do that with you. But again, number 1 and number 3 specifically are the big differences I want you to look at.